Okay, so video number 4, we're on problem number 5 here. We want to find the lengths of the sides of a right triangle if the hypotenuse is 10 centimeters longer than the shorter leg and the other leg is 5 centimeters longer than the shorter leg. So the key with problems like this is to find out what they're not talking about and everything else is being compared to that. And you see what's in yellow is the shorter leg. So everything is kind of leading to naming the variable x as the shorter leg. So you're comparing the hypotenuse is 10 centimeters longer than the shorter leg. So that would, of course, be then, since we named our shorter leg x, then the hypotenuse then would be x plus 10. And I'm going to just put that over here. And then the longer side, then the other leg is 5 centimeters longer than the shorter leg. The shorter leg is then x, and this would be x plus 5. So now when we set this up, since it's a right triangle, you have a squared plus b squared is equal to c squared. So I'm going to just write the a just to kind of stay in line with the formula. And c is, of course, opposite the 90-degree angle. So here we go. We have the quantity x plus 5 squared plus then we have x squared is equal to the quantity x plus 10 squared. On the left-hand side, you can do this by hand. When you multiply x plus 5 squared, you're going to get x squared plus 5x plus 5x plus 25. And then you're going to get x squared plus 10x plus 25. So that would be the first quantity that we're talking about here. So then that would be x squared plus 10x plus 25 plus x squared is then on the right-hand side where we have x plus 10 squared. It would be x plus 10 times x plus 10. And if we FOIL that, we're going to get x squared plus 10x plus 10x plus 100. And that would then be x squared plus 20x plus 100. And that goes on the right-hand side of the equation. So we have x squared plus 20x plus 100. So now what I'm going to do is I'm going to combine I have a 2x squared on the right-hand side. I'm just going to do one more line. Bring everything down. And now I'm going to take and subtract what's on the left-hand side, what's on the right-hand side from both sides of the equations. So then on the left-hand side, x squared minus 20x and then minus 100. So that on the left-hand side, I'm going to have x squared minus 10x minus 75 equals 0. So this is the same as another problem where if we're solving quadratic equations, what we want to do is we want to make sure that we're setting our quadratic equation ax squared plus bx plus c equal to 0, and then we're going to try to factor. Now, factoring is always the first thing I would try. So I would say to get the first, it would be an x times an x. And if you want to do that little thing where we were saying the factors of negative 75 that sum to negative 10, and let's see what we get here. The 15 goes into 75, 15 times 5, and then we have a 15, a sum means you're going to add 15 plus 5. So one of them has to be negative, and it's got to be the 15, because you have negative 15 plus 5 has to be a negative 10. So then we have x minus 15 and x plus 5 is equal to 0. So then we get x, using the principle of zero products, we would have then x minus 15 is equal to 0, or we would have x plus 5 is equal to 0. So we get x is equal to 15, or x is equal to -5. And it turns out that -5 is going to be extraneous because you can't have a distance of a triangle side being negative. So we know that x is 15, so we know that the shorter leg in the triangle is 15. Let me go to a different color then. We would have the shorter leg is equal to 15. And they would have x, so we would have, I didn't write 15 there, 15. And then we would have, then the longer side would be 15 plus 5, or would be 20, so the longer side would be 20. And then they would have 15 plus 10, and then we'd have 25. So the sides of the triangle, the sides would be 15, 20, and 25. Now, an interesting way to check this would be to say 15 squared plus 20 squared would have to be 25 squared, and we know 25 squared is 625, so we have 400. 15 squared is 225, and certainly it checks out. Okay, so that's a neat little Pythagorean theorem, but kind of in with the quadratic solving as well. So cool problem. One more that we'll do, number 6, is reducing a rational expression. Now we've moved on to a different topic, where a rational expression is then, of course, a fraction. But it's a fraction where the numerator and denominator, here's your numerator, here's your denominator, are polynomial expressions. So in order to simplify them, we want to reduce to lowest terms, so that's what this term means. These words, simplify. So if we're going to simplify this, we want to, remember this word from class, factor, cancel, and simplify. And I think in class I said, remember, it's FCS. So let me change over to a blue pen. So I'm going to factor the numerator, and I'm using an equal sign there just to show you that this expression I'm going to write is equivalent. So if I factor the top, all I can do is factor out right now is a common factor of x, which then leaves me with 4 minus x squared. And in the bottom, I can also factor an x, and then that leaves me with x squared minus 4x plus 4. The two x's then cancel as common factors. I like to use a different color when I cancel. They become 1s. And then I'm going to factor the numerator still. I've got the difference of 2 squares, and we referred to that already in our factoring. So the difference of 2 squares is going to factor as 2 binomials. And remember that 4 is 2 squared. So it would be 2 plus x and 2 minus x as the binomial factors. And you can refer to that in one of the first problems above for the formula. And then in the denominator, what we have x minus 2 and then another x minus 2 when we factor that. Again, we're looking for the factors of 4 that sum to -4, and that would be minus 2 and minus 2. If you recall, then we have an x minus 2 and a 2 minus x, and they don't cancel as 1, but they cancel as -1. So our final answer when we simplify this expression then is, we're going to leave the -1 out front here for just a second, and then I have 2 plus x in the top, and in the bottom all I have left is the x minus 2. Now, one of the things that I like to do is I like to take the negative sign and apply it where I think it could be easiest or make sense to me in terms of simplifying the expression. If you think about it, the negative sign, you have one negative sign in the fraction. You could leave that here, or you could put it down here. And so that's what I'm going to do. It's kind of like if you have a 2/3. If you have -2/3, it's equal to 2 over -3. And we could take that negative sign and we could move it from the top to the bottom. So I'm going to move the negative sign in the bottom, and we do have an x minus 2. and in the top, I just have that 2 plus x. Now, what I'm going to do is I'm going to distribute the negative sign here, and I'm going to make the top, I'm going to keep the top as 2 plus x, and then the bottom, I'm going to rewrite that as 2 minus x. So this is the lowest terms for that fraction. I don't know why that happens when I do that, but there you go. Okay, that's the lowest terms. Now, I'm not saying what x can't be, but certainly x cannot be 2 in this problem, you know, just in case that is a concern, because your denominator would equal 0. It also can't be 0, because in the beginning, if we had 0 here, here, and here, we'd clearly have a 0 denominator. So you've got to include both if we're going to have a discussion about that. Okay, just added that in there for free. So I'm going to come back to problem number 7 in the next video, and ciao for now, and see you soon. This is Mrs. Allen signing off.